Okay, so in this video, we discuss all about the limits. So what is limit? So let f be a function that is defined on an open interval containing e, but possibly not defined at e itself. So let L be a real number. So that is the limit f of x, which x approaches to e. Okay, so is equals to L. Okay, then defines the limit of the f of x at a point e. So L is the value that the function has as the point e is approaching. So next, finding the limits graphically and numerically. So for example, from this problem given, so find the limit of the function as x is approaches to 1 from the given problem. So sketch also the graph. Okay, so we have the given, which is f of x is equals to x cubed minus 1, then over the x minus 1. So we have the given also the domain, which is the x values. Okay, 0.75, 0.9, 0.99, 0.9999. So 1 and then 1.001. Okay, so 1.01, 1.1, then 1.25. Okay, so f of x. Okay, so we find later on. So solution. So here is the problem given. Okay, so to find the value f of x, or to find the range values, we have the first 0.75. So substitute f of 0.75 is equals to 0.75 cube minus 1 over the 0.75 minus 1. So where f of 0.75 is equals to 2.313. Okay, so that is the result to be calculated. Okay, so the same process where f of 0.9 is equivalent to 2.710. So another is the equivalent of f of 0.99, so is equals to 2.97. The next is f 0.999, so that is equivalent of 2.997. Okay, so the other side, which is f of 1.001, that is equivalent of 3.003. So another is f of 1.01, that is also the equivalent of 3.030. The next, f of 1.1, that is equivalent of 3.310. And then the last, okay, so f of 1.25, okay, so is equals to 3.813. Okay, so therefore we found out this value, or the range value of f of x. So take note, we cannot substitute 1 here. Okay, so we all know that this numerator or the denominator, if you substitute the value of 1, so it will become a 0. Then the result is 0 over 0. So that is called the indeterminate. Okay, we cannot say also that f of x here, when x approaches to 1, will be the result is 0. Okay, so because we all know that the answer, which is the approaches to 1, is 3. Okay, so because this value is closest to 3, and the right side also closest to 3. So this is the express also the where e na to is 1, then is equals to the limit x cubed minus 1 over the x minus 1, where x is approaches to 0. So here is the graph. So I cannot put coordinates here, but I put also this coordinate. So Okay, so again, so we cannot say that when x is approaches to 0, that is possible, or the answer is 0. Okay, we cannot define, no. Okay, so therefore graph of f is parabola, so that has a hole at the point 1 and 3, no. So although x cannot equal to 1, so you can move arbitrarily close to 1. Okay, so here, and as a result, f of x moves arbitrarily close to 3. The limit of f of x as x approaches 1 is 3. Here is the answer. Okay, so we have another solution from the given previous slide. So which is f of x is equals to x cubed minus 1 over x minus 1. And then with the use of synthetic division, so we can say that x minus 1 or x is equals to 1. Okay, then we have the x cubed minus 1. So we use this. So we can say that 1 here, which is the exponent of 3. Then we put here a 0, which is the exponent is 2. Another 0, exponent of 1. And then the whole number, which is a negative 1. Also, we put here. And then we put the value of x here in the left side. Okay. So now we can bring down this one. Okay. And then we can multiply. Okay, 1 times 1, that is 1. Again, we can add this 0 plus 1, that is 1. So another 1 times 1, that is 1 also. Then add, that is 1. Then times multiply by 1, that is 1. Then add, so therefore we can say that our remainder is 0. Okay, so we can express this by x squared plus x plus 1. Okay, so that is the result of this, no? Or another else, we can use the remainder theorem. So like this process, no? Okay, so x cubed minus 1 divided by x minus 1. Okay, so we put here x squared, so multiply x squared times x equals or x squared times x minus 1, that is the equivalent of x cubed minus x squared. So we have the positive x squared, so the positive change into negative, then a negative is change into positive. So that is the role of in determining the this division. Okay, so we make positive to negative, so again negative to positive, so therefore the result is x squared minus 1. So we can bring now the negative 1 here. Okay, so again we put here as positive x, so therefore x times x, that is x squared, so x times negative 1, that is x, so here negative x. Okay, so again we change this positive into negative, then negative into positive, so therefore the result is x minus 1. Okay, so again we put here a positive 1. Okay, so therefore so positive 1 times x minus 1, so therefore the result is x minus 1, and then the remainder is equivalent to 0. So either of the two theorem, okay, or the process in solving or the simplify it is given, no? Okay, so we come up the same answer, okay, which is x squared plus x plus 1. Okay, so therefore we can use that in this limit, which is limit of x cubed minus 1 over x minus 1, which x approaches to 1. Okay, so right here from here to here, no? Again, so now we can substitute the value of 1 or x approaches to 1. Okay, so therefore 1 squared then plus 1 plus 1. So therefore the answer is the limit of x cubed minus 1 over x minus 1, where x is approaches to 1, and that is the equivalent to 3. So that is the answer. So the process of solution is called analytic approach. From the previous slide, that is a graphical approach, or another term, or another is numerical approach. Okay, so when you say analytic approach, it contains with the use of algebra. Okay, then when we say the graphical approach, okay, so you can graph. Okay, then another is a numerical approach. You can construct table. This is another way, so way of and solving the solution in terms of limits.